Hello everyone, welcome to Payment Tech Media. This is another example of IP version for Class C subnetting. So let's go and jump into my computer and have a look. Let's say they gave us the network address of 192.168.1.0 network and default subnet mask, the CIDR notation 24 for Class C, 192, that's Class C network. So the default subnet mask, very good, 255.255.255.0. But the question they're asking that we don't want to use default subnet mask because it will give us up to 254 available IP addresses, but we don't want to waste too many IP addresses. So they said we only need 20 IP addresses. So they only need 20 IP addresses. They don't want 254. So we need to do subnetting, breaking a large network into the smaller network. Okay, so the default subnet mask here, Class C, 255.255.255.0 means the first octet, it's all turned on for the network bits. The second octet also turned on for the network bits. And again, ones represents the network bits, zeros represents the host bits, and 1 means on, 0 means off in the binary number system. Okay, so here on a third octet, 255 also means 8 bits turned on, because again, anytime when we have in the binary all the 8 bits turned on, here the decimal values 128 plus 64 plus 32, because all of them turned on, it will give us 255. And the last octet, it's pretty much all turned off. Okay, so they are asking for 20 hosts or 20 available IP addresses. So earlier we talked about the number of hosts, 2 to the power of host bits minus 2 to get the available IP addresses, right? Number of hosts. We take out the network address and the broadcast address, so that's why we do the minus 2. And number of subnets, 2 to the power of subnet bits gives us the number of subnets. So they said 20 hosts. One way to find out, we can just simply count at the bottom going from right to left, starting with number 2. So 2, 4, 8, 16, 32, and again it's by block, so block size 2, 4, 8, 16, 32. Here minus 2, it gives us 30. Very good. They're asking for 20 hosts, so here it's perfect. We can just stop here for the number of host bits, for the number of zeros. Because if we stop here at 16, it's not enough. We need 20. So let's draw a cut line here. And we need to borrow from these host bits. So these are turned on. And this is our cut line. These are turned off. Yes, they did ask for the 20 hosts. And the closest block that meets our requirements is this one. If we apply the formula, so here how many host bits do we have? 1, 2, 3, 4, 5, right? So 2 to the power of host bits minus 2. So 2 to the power of how many host bits? 5 minus 2. So that's 32 minus 2, and that's 30. How many subnets? 2 to the power of subnet bits. How many subnet bits we have? 1, 2, 3. So 2 to the power of 3, which is pretty much kind of same formula applies if we count going from left to right, starting with 2, 4, 8. So left to right, starting with number 2, that's for the number of subnets, and going right to left, starting with number 2, and then at the end minus 2, that's number of hosts. This is also another way to find out. So let's apply this formula. We said 3 subnet bits, 2 to the power of 3 equals, so that gives us 8. 2 times 2 times 2, right? So 2 times 2, that's 4. And then 4 times 2, that's 8. So that's 8 subnets. So this network address with the default subnet mask, if we need 20 hosts per subnet, what is our new subnet mask? So our new subnet mask, it's not 255.255.255.0 anymore. So what is our new subnet mask? Well, we have to count all the number of ones, right? And then converting these binaries to decimal. So let's convert how many we have here, 8 ones. So in this octet, all the bits turned on. We just need to add these decimal values. So here we have 255. And the second octet also all turned on, so that's 255. The third octet all turned on, that's 255. And the fourth octet, we have the binary value 1110000. So we just need to add the ones that is turned on. In this case, 128 turned on, 64 and 32. So 128 plus 64, that's 192, plus 32, that's 224. So this is our new subnet mask, and the CIDR notation would be, well, 8 plus 8, 16, plus 8, 24, 25, 26, 27. We are counting the ones, right? Network bits. So it is CIDR notation of /27. So anytime when we have this network address of 192.168.1.0 with the CIDR notation of 27, or the subnet mask of 255.255.255.224, it will give us 30 available IP addresses per subnet. And we will have up to 8 subnets. Each subnet, 30 available IP addresses. Let's see it in action. So let's erase all this. So it is 27 now, which is 255, 255, 255, 224, and they said 20 hosts. But of course, we will go by block, right? And this block is the closest one that meets our requirements and not wasting too many IP addresses, which gives us a 30. So this is our network address, the first 0 network, 192.168.1.0. What is the next subnet? What will be the increment? You guys remember earlier we talked about the last bit that is turned on. In this case, this is the last bit after we did the subnetting. So this is the last bit turned on. The decimal value is 32. So 32 is our network increment. So we are incrementing by 32 on the last octet. So next subnet would be 192.168.1.32. The next subnet would be 192.168.1.64. Next one would be 192.168.1.64 plus 32, 96. And if we continue incrementing by 32, right? So 192.168.1.128. 128 plus 32 is 160. So 192.168.1.160. 160 plus 32, 192. So 192.168.1.192. 192 plus 32, 192.168.1.192 plus 32, it is 224. And 224 plus 32 is 256. So 192.168.1.256. And I did use a different color. So of course we don't have 256 in octet. So here we can see this is our first subnet, second, third, fourth, fifth, sixth, seventh, and 8 here. So this 256, it's not valid. Therefore, this CIDR notation of 27 will give us 8 different subnets, which applying the formula here we saw the number of subnets going from left to right, starting with 2, 2, 4, 8 number of subnets. and the number of hosts going from right to left, starting with number of 2, 2, 4, 8, 16, 32 minus 2 because of the network address and a broadcast address to get the available number of IP addresses. So every subnet will have 30 IP addresses. Let's find out. So if this is our range, and this column is the network addresses, and this column here is the broadcast addresses. So for the first subnet, the broadcast address is one less than the next one. So the next one is 1.32. Therefore, the broadcast address would be 192.168.1.31. And here, if we go through the range, 192.168.1, 192.168.1.1, and it goes to, this is the first available IP address in this subnet, and it goes to one less than broadcast, so 192.168.1.30. So here we can see 1.1 to 1.30. That's 30 available IP addresses here, as we can see. So every subnet gives us 30 available IP addresses. The next subnet, 192.168.1.32, correct? Incrementing by 32, the last bit turned on. So this one, what will be the broadcast address for this subnetwork? So the broadcast address is always one less than the next subnetwork or the next network. So then in this case, next subnetwork is 64. So it would be 192.168.1.63. So for this subnet, 192.168.1.32, the broadcast address is 192.168.1.63. And the range is, the available IP addresses in that subnet is 192.168.1.32, that's a network. The next available, 33. So here we can see in this subnet, 192.168.1.32, the first available IP address, 192.168.1.33, and it goes to 192.168.1.1 less than the broadcast, 62. Because the broadcast address is 192.168.1.63, one less than the next subnet, right? So that's a broadcast address, that's a network address, and these are the available IP addresses for this subnet. And here we can see also we should have 30 available IP addresses. So 1.33 to 1.62, that's a total of 30 available IP addresses. And same thing applies for the next subnet. We should have 30 available IP addresses. And again, the broadcast address, one less than the next one. So what will be the broadcast address for this subnet? If the next subnet is 192.168.1.96, so one less is 1.95, right? So that's a broadcast address for this subnet. So 192.168.1.95. And the available IP addresses in between. So the first available IP address is 192.168.1.65, and it goes to 192.168.1.1 less than the broadcast, 94. And again, 1.65 to 1.94, that's a total of 30 available IP addresses. So the 0 bits, that's the host bits, 1s, that's the network bits. And here we borrowed 3 bits, so that these are our subnet bits. And we talked about the number of subnets left to right. 2, 4, 8 gives us 8 subnets. Each subnet we can have 30 available IP addresses. The number of IP addresses we can count going from right to left, 2, 4, 8, 16, 32, and minus 2 because of the network address and the broadcast address. So we have 30 available IP addresses per subnet. Well, this was another example of IPv4 Class C subnetting. I hope it was useful and helpful. In the next videos, we will talk about Class B and Class A subnetting. Thanks for watching and have a good day.